I just want to review the tangent ratio. So take a look. We're going to define the tangent ratio for acute angles of a right triangle. Let's get that in there. This is really only for a right triangle. So this document you see on the video is the same document that's attached to tonight's assignment. Solve right triangle problems by using the tangent ratio. Now the tangent ratio, remember, if you identify an angle, is going to compare the two sides. So tangent of any angle is going to be the opposite side or the opposite leg compared by division with the adjacent leg. The hypotenuse distance or value or length isn't going to be part of any of the tangent ratio exercises. Tomorrow we'll introduce two more ratios that use the hypotenuse. For now, let's just get really good at tangent. The tangent of the angle at P in example 1 is shown to be 15 over 8. Well, why is that? The length of the leg opposite P is 15. The length of the leg next to P is 8. So tangent of the angle at P equals opposite over adjacent. These are both distances, and this is a ratio of 15 over 8. No matter how much larger this triangle gets, as long as it's a right triangle with the same angle at P, it's going to be similar. Therefore, the ratio will stay 15 to 8. So in this first example, you're just asked to express the tangent of x and the tangent of y as ratios. So let's do number 4. There's going to be some radical terms in here, so you've got to do a little digging to go back to your algebra days. In this case, the tangent of the angle at x, let's highlight that angle, as always, tangent is opposite over adjacent. And I'm having a little trouble reading that angle. Oh, I see. It's an 8 equals 8 over 8. Well, the tangent of x equals 1 because the opposite compared to the adjacent for x is equal to 8 over 8. Now the interesting thing is that the tangent of y in example 4 also equals the opposite over the adjacent is 8 over 8. Well, how can that be? The two legs still have measures 8 and 8. So I know right away that this is a 45, 45, 90 triangle simply because that's the only time the two legs have a ratio of 1 to 1. And this is a really interesting hypotenuse, and it's going to keep coming back to us, this square root of 2. So as part of tonight's homework, you'll be asked to finish 1, 2, and 3, that same way. And let's correct the directions here. In example 2, I want you to use your calculator. Your calculator is programmed with the same tables from page 202, but this is a different text, so don't look through your text for the table. Your text assumes you'll be using a calculator. So you're pushing the buttons first for tangent of 45, because you know that should equal 1. If you get something other than 1, you know you're in the wrong mode. Now push the buttons for tangent of 20 and see what you get. Does your value match the one given in the text? Here's an interesting question for B. How do I get back to the angle? Well, you've got a second button that allows you to access any of the commands that are above your keys. So above my tangent key, I have this inverse tangent command. Well, I'm going to use the inverse tangent to find the angle. If I know the ratio, and here it is, then I can use the inverse to find the angle. If I know the ratio, I can use the inverse to find the angle. So step 1, locate 4.0108 in the tangent column. We're not going to do that. We're going to locate the inverse key on our calculator. So you're going to hit the second button, followed by the tangent button, which is going to activate the inverse tangent function. It's going to open a parenthesis, and you're going to enter 4.0108. That's the ratio you were given. Tangent of what angle equals 4.0108. Then you're going to hit the enter button. And hopefully the value you get is 76 degrees. And to fill that in, you use tangent 76 equals 4.018. Replay this part of the tape if you're having trouble with any of the exercises that look like 9 or 10. So this is just getting used to your calculator. You're going to be asked to complete 5, 6, 7, 8, 9, and 10 using your calculator. For the direct tangent function, simply press the tangent button. This gives you the ratio. When you know the ratio, press the inverse tangent by using the second key, because this gives you the angle. And then we're going to solve some problems using the tangent. In 11, I can find the value of x to the nearest tenth. I'm going to redraw the triangle, and so are you. I learn a lot about my triangle, and I can actually plan a strategy. Tangent of 37 equals x over 25. I'm going to bust the fraction by multiplying both sides by x. 25 multiplied by the tangent of 37, and I can enter this all in one motion or in one expression with my calculator. I don't need to simplify tangent of 37 because my calculator knows what that is. It's just a number. And when I punch in these buttons just like this, 25 tangent of 30 is approximately 18.84. So go ahead and finish 12, 13, and 14. In example 4, you're asked to find y. Now you know that the ratio is given based on the two legs. So for this guy, you're going to need to solve for x using the Pythagorean theorem. But for this guy, you have an opposite and you have an adjacent, so you know that the tangent of y degrees equals 5 over 4. So use the inverse tangent key or the second tangent button and enter that ratio, and you're going to get the angle of 51 degrees. So check with your calculator. Second tangent, 5 over 4, 51.34 degrees. So approximately 51 degrees. And we're going to do a couple of these angle of elevation problems just to review. So you're drawing the situation. You're labeling change in x. You're labeling change in y. You're writing a trig or a tangent equation. And you're solving that equation using a fraction buster technique, showing the multiplication to both sides. So from a point 80 meters from the base of a tower, we're looking at number 1, the angle of elevation to the top of the tower is 28 degrees. Well, that's drawn in already. That's inside the triangle. Do you remember that the angle of elevation is congruent to the angle of depression, which is outside the triangle? How tall is the tower? Well, in this case, I have the tangent of 28 degrees equals the opposite over the adjacent. Now, you're watching me continue to write opposite over adjacent. I do that to help reinforce my understanding that this is a ratio of the legs across from the angle compared by division to the leg next to the angle. I would be writing it this way if I were you. Equals x over 80. So tangent of 28 equals x over 80. Didn't mean to make that 28 look like it was a numerator. I'm going to bust the fraction by multiplying by 80. And 80 tangent 28 should give me x exactly. The minute, though, I round the value out of the calculator, I need to say x is approximately 42.54. And was it meters? It was meters. So use that method for completing the application exercises you're assigned to. Post questions to Schoology. Respond to the questions of others.